I would like to welcome Dr. Steve Davis, Chief Science Officer with the Everglades Foundation. Dr. Davis is an aquatic ecologist with 25 years of research in the coastal Everglades. He draws upon his past professional experience, including 10 years as a professor of wetland ecology at Texas A&M, to lead the Everglades Foundation's science department and science communication efforts focused on advancing Everglades restoration, tracking ecosystem health, and understanding the impacts of sea level rise. Steve, whenever you're ready.
Thanks, Mike, and thanks to Florida for the invitation to present perhaps our greatest water challenge, certainly in South Florida, and that's Everglades Restoration. We're a science-based advocacy organization that's focused on advancing Everglades restoration and protection of this ecosystem, because we recognize the connection between the health of this greater Everglades ecosystem and our economy. Obviously, that's based on real estate, tourism, other aspects that really attract people to South Florida. As a science program within this organization, we work to advance restoration as best we can, and we do that through science and modeling to inform the decision-making process. We verify agency science. The lead agencies involved with Everglades restoration are the Army Corps of Engineers at the federal level and the South Florida Water Management District at the state level. We lead and facilitate and collaborate on new research to help advance that mission. And I see some of our colleagues from different universities across the state on here, and look forward to connecting with them. We look at the economics of this as well. We know that economics, certainly return on investment, is an important driver of the decision-making process. We communicate science broadly. As a scientist, I certainly know the value of peer-reviewed publication and bringing credibility to our work. But we also communicate broadly to business groups, to stakeholders, and all levels of government. We also invest in graduate and undergraduate level research to help us advance our mission, realizing that the institutions, the universities, that's really the hotbed of new ideas and innovation. So tapping into that is critical to us. And when people think of Everglades restoration, they might have this image of these different habitats or systems that comprise the Everglades. And really it starts with this, because these areas are all connected by clean fresh water. We get 4 to 5 feet of rainfall each year in South Florida. And it was that natural Everglades ecosystem that would manage this water and convey it across the flat, low sloping landscape that we have here in South Florida. But to understand the water challenge that we face, it's important to look back. And of course, we didn't have a satellite flying over Florida in the late 1800s, but if we did, it would look something like the image on the left, where you had a continuous flowing system that was fed by the Lake Okeechobee watershed all the way up to just south of Orlando. And the lake would spill over south during wet years into that river of grass, which was in some areas 50 to 60 miles wide. That narrow rock ridge that we developed in South Florida is the high ground, and water would shoot through those gaps into coastal areas like Biscayne Bay, and then eventually that sheet would make its way all the way down to the southwest coast and into Florida Bay and the Florida Keys. And we have half of that ecosystem remaining. Much of it is compartmentalized. Everglades National Park at the southernmost end is deprived of fresh water. Florida Bay suffers from extreme hypersalinity during drought years. And we have this massive agricultural area on drained peat soils that disconnects the Everglades from Lake Okeechobee. So the problem that resulted from this major plumbing overhaul that began nearly a century ago is that water from Lake Okeechobee is discharged east and west into just extraordinarily large volumes to the Caloosahatchee estuary, to the St. Lucie. These unnatural volumes of fresh water alone are impactful to those estuaries and those communities. When you add in the fact that the lake is a polluted, impaired water body that supports the growth of toxic blue-green algae nearly every year, When those discharges are made, it's not only carrying those harmful volumes of fresh water, it's carrying toxins, it's carrying blue-green algae that translates to impact in those communities around those estuaries. It's not just environmental harm at that point, it's economic harm, it's impacts to real estate, human health, tourism, etc. The fact that we're not getting enough fresh water to the south means that we have problems with water supplies. I'll talk about this in a little bit, but the lower East Coast water supply, primary water supply, comes from underneath the Everglades. We see an increased severity and frequency of fires to the point where we have years where those peat soils actually catch fire, causing permanent loss of habitat. And to the south, we see algal blooms and seagrass die-offs associated simply with the fact that we're not getting enough fresh water. So these water quality and quantity problems are really the focus of Everglades Restoration, which many of you know is a collection of projects around South Florida. And those identified in red here are those that are currently authorized and under construction. I point out the EAA Reservoir, the Everglades Agricultural Area Reservoir. This is on a 17,000 acre footprint. You can fit the island of Manhattan in this project, just to give you an idea of the scale. This project is currently under construction. It is the pivotal piece for Everglades Restoration. I've referred to it as the flux capacitor. If you know Back to the Future, the movie, the Everglades Reservoir is what makes restoration work, because it takes water that would otherwise be discharged along the Caloosahatchee, St. Lucie, and sends it south in enormous quantities of new flow going south. And the way we deal with the water quality problem, because the lake is polluted, because the runoff from those sugar fields south of the lake is polluted, the state has invested nearly $3 billion in treatment wetlands, wetlands that are managed solely for the purpose of removing phosphorus pollution out of that water before it goes to the Everglades, so that we're ensuring clean water goes south. And again, the less clean, or the more clean water we send south, the less of that polluted water we're dumping to the east and west coasts. Further downstream, the plumbing to get this water through the Everglades into Everglades National Park along Tamiami Trail have been built. We've got 3.3 miles of this bridging, and the final phase of this Tamiami Trail project is underway currently, slated for completion in July 2024. That will elevate the remaining roadbed between the bridges to ensure that we can get restoration quantities of flow going into this World Heritage Site, International Biosphere Reserve that is Everglades National Park. And it's not just the EAA Reservoir. These are massive water infrastructure projects. The image on the upper left is the C-43 Reservoir. That's a 10,000 acre footprint. You can fit O'Hare Airport and Miami International Airport in that footprint. We've got the C-44 project that's been completed, bridges of Tamiami Trail, lots of pump structures that help us to move water where we want it and to keep it from going into communities where we don't want it. And again, this is fundamentally about our water supply in South Florida. 9 million plus in South Florida, 42% of our state's population get their water from the greater Everglades ecosystem, and over 5 million depend on the Everglades for their primary water supply, recharged by the Biscayne Aquifer. So basically Southern Palm Beach County all the way down to the Florida Keys gets their water from this system. The more water we send south, the more we ensure protection of water supplies and build resilience for the future, knowing what we know about climate change, storing that 4 to 5 feet of rainfall we get each year as much as we can rather than wasting it to tide is certainly in our best interest. And ultimately, the finish line, getting water through that mangrove ecotone out into estuaries so we can protect our seagrass meadows, we can protect our massive expanse of mangrove forest, and ensure that these systems are sequestering carbon as they should and providing habitat to a variety of species that are both functionally and recreationally important. Thanks.